Swayam Prabha. Digital India. Educated India.
Hello and welcome to this new experiment on vacuum forming. It's a process which is highly used and recognized by the industry to do packaging, particularly of parts, plastic parts, etc. However, our interest is sort of micro machining and micro fabrication. So therefore, in this particular aspect also, we can actually vacuum form plastic sheets into devices which can be used for microfluidic applications. So I am going to now illustrate the basic process that how the vacuum forming can be done, and then later on demonstrate one example of forming, okay, which would typically mean to take a plastic sheet of ABS and then trying to heat it to its forming temperature. Okay, so the basic idea here is that supposing there is a very complex mold which you want to cover with plastic in the interest of packaging this, and you can see here this is the 4i laboratory written on a rapid prototyped part, which has been done using another plastic, ABS plastic through the RP machine. Okay, and so basically we want to create a situation where we want to package this using another plastic. So this right here is the controller for this machine, and the way to switch it on is basically create the main power inlet into the system by turning on this MCB. Following by, you can see there is an auto and manual option. The controller can be taken into both modes. We are going to do manual here, so we just put it towards the manual side, and then go to the next step, heater, and try to switch on the heater, which brings in the signals in all the different heating zones. Okay, so this heater is actually controlling the unit right here, which is actually an infrared heater with set of elements which are all round, and these are going to provide uniform heating to this sheet later on, as this heater is going to come exactly over this sheet, and it's going to heat this sheet all the way to its forming temperature, so that it becomes it becomes in a plastic flow state and can actually with vacuum be pulled into a complex architecture which has been placed in between in this particular sheet. So after doing this heater on, we can actually switch on the vacuum pump. Okay, a certain vacuum pressure to be put in, particularly in this unit, which would be able to take this sheet which is in the plastic state now and try to form it over the surface that we are concerned with. So this right here is the ABS plastic sheet which is going to be heated to the forming temperature so that it can form around the particular part, creating the packaging. What we have to do here is to put this sheet right in this particular position, and you can see here, right here, that there is a rubber packing which is there to actually create a good seal between the sheet and this plastic sheet and the metal body. Okay, and what we are also going to, so therefore, the idea is that this goes over that particular region which would actually vacuum pull, and we need the vacuum to not leak. Okay, so therefore this right here is the rubber seal for that. There is also a clamp here which goes down all the way to this to grab this sheet over this particular rubber packing or casing which is there, and then you can actually fit this sheet tightly over the top of the system. Now you can ensure that as the sheet would, this table would come up with the workpiece and come all the way here, there would be a proper sealing of the vacuum between the table and the top portion of the plastic sheet. Okay, so once this is done, now we have mounted the cover which is going to be formed. We have also mounted the sample in the stage. So there are two samples here, as I showed you. This sample is going to be embedded within this or the packaged within this particular material. So I'm going to put this sample in this manner, okay, right here, and there is another sample which I would like to just demonstrate, because the question of micro machining comes. So basically this is a aircraft fuselage. This has also been developed with rapid prototyping system, and we are going to package both of them together, okay, at a single go. So I'm going to put this 4i laboratory inside, and then I am going to just put this aircraft fuselage. You can see this is the fuselage, okay, again parallel to this, so that you can see the resolution at which this forming process can happen or take place. Okay, so I am going to just align this properly and put the aircraft fuselage just along with this tab written with 4i lab. Okay, so once this is done, now we are set with the work sample on the work stage. We are also set with the forming sheet, the ABS sheet, and we have duly clamped it. We have ensured that the vacuum doesn't escape, and now we start the system on for the forming process to happen. Coming back to this controller now, we have to now turn on the heater. Okay, so there is a switch you can see here for the heater. So as soon as the heater is on, you can see that the stage actually brings the heater all the way to this particular sheet, and then we want to see, and you can actually see inside. If you go inside, it's very difficult for the camera, but the wrinkles are disappearing in the sheet. And if it is fully wrinkle free, in that event, what we want to do is to sort of hit this particular table and take this particular heater back at the same time. Okay, so we just hit this table on and take this heater all the way back, and as you can see here, the moment it has come, you just turn on the vacuum, so that the ABS plastic sheet now has formulated completely over these two features, so that you have a proper packaging of the system as such, and there is no vacuum leakage between the same. You can see this particular part as well as this particular part has been fully packaged with the system. The idea behind this particular forming process is that if the feature size is very small, let's say for example in the case of micro channels, we want to build the channel out of some kind of a plastic sheet, let's say acrylic sheet with laser machining, etc. We can easily use this secondary plastic, this ABS plastic, to be vacuum formed over those molds, so that we can eventually formulate these channels. So what we are going to do is, there is a switch on this controller right here for the fan. So this switches on the fan, so that there is a heat transfer because of forced convection, and there is a removal of the heat, so that the surface temperature of this particular ABS plastic comes down. And once this is done, what we can do is basically use this particular emergency switch to actually create small pressure blows, so that we can remove this particular acrylic sheet out of this structure, after which we do the vacuum off, okay, and then we try to take this table down once more. So the table goes all the way down here, and you can see now that this is a well formed structure formulating out of these particular objects, and the sheet beautifully formulated, thus packaging these objects within the stage. I can actually remove the structures, okay, from this particular sheet, and I will show you the formulation later on once this has been done. So all this has come down, and if we remove this particular sheet here, okay, I can see that this is a well formed sheet over the structure that has been formulated. So this is how you do the whole vacuum forming process. So you can see the two forms right here. This is the packaging of the 4i laboratory. This again is the packaging of that particular fuselage of the aircraft. We have just kept it for representational purposes. And the idea here is that very small features can also be very well formed with this particular method. Okay, and in future we have a scope of doing microfluidics using this particular sheet itself, which is formulated in terms of, or in shapes and sizes of micro channels, okay, and then we can inject through these sheets and puncture these sheets very easily through syringe needles. And so we are soon going to bring out a module where we can show how these microfluidic channels are drawn by such vacuum forming processes. So as you can see, this particular feature right here, this is that fuselage feature, is comprised of various different shapes and sizes, contours, edges, which are even thin. And so the idea is that the process is capable of doing forming across such edges. And this is itself a very big, it gives a lot of, it says a lot of things about the process capability of such system. So in a nutshell, vacuum forming here, although is used in the majority of the cases for packaging, can also be used for creating micro devices and micro features. Okay. And this is a very useful tool which is going to provide some of the very amenable disposable kind of plastic systems which can handle microflows within small domains. Also, one more important thing that I would like to mention here is that once the sheet is heated to a certain structure, and supposing you want to by any chance you have committed an error and you want to just reuse this particular sheet. So, there is an option which is available if you just do not remove the sheet at that particular instance from the machine itself, and you just heat the formulated sheet or the formed sheet again with a set of heaters. There are a few cycles up to which the sheet can sustain itself. Only thing you have to see inside is that the wrinkles are totally eliminated, because the next before the next round of forming operation starts to take place. So, in a way it is a reusable plastic, making amenable the ABS plastic sheet which formulates a cover material in this case to be reused many times up till it achieves its because of repeated plastic flow, probably the sectional thickness comes to a level where there can be failure. Okay. So, before the sheet has hit that particular thickness, which is also called the failure thickness, you can reuse the sheets again and again for doing this forming process. So, the whole vacuum forming unit consists of 3 different components. One is or 3 different modules. One is this main forming unit, which is comprised of a series of infrared heaters, okay, which is just underneath this box here. The box is capable of movement. So, it comes and slides along the guide rails all the way to the top of this particular area. It also comprises of a clamp where you can open and close this clamp, which can actually be used to clamp the plastic sheet to the machine. There is in fact a spacer which actually determines that there is complete vacuum retention when the vacuum pressure is introduced. There is a work table on this particular sheet which is having small holes through which the vacuum can surpass, and the idea is to pull the sheet after heating it to the forming temperature, so that it sits on the top of these small objects. This is one unit. The other unit here is the controller set, which is used to drive this unit here for its different operations like heated temperature control, heated timer on. Process can be automatic or manual. So, there is an option where you can actually program the process for a few minutes of heating. Typically, the heating time which is needed for ABS plastic that I will be demonstrating later on is close to about 1.5 minutes, and the way you see it is also to when the plastic is being heated, you will see the wrinkles appear and then they disappear, meaning thereby the plastic has come into its totally flow state, and this is also known as the forming temperature of the material. Okay. There is a fan unit here which is used in case the plastic has been fully formulated over the surface to cool down rapidly. So, you can have forced convection which will cool down the plastic which has been formed, and there is a compressor set right here which is also a part of this module, because you need to generate a sort of vacuum level for feeding this machine, so that you can have vacuum assisted forming. Okay. So, in fact, this whole unit comes in these 3 parts: the main unit, the controller, and the compressor.